Hi, my name is Blair, and I'm working on the Realtime project. One of the more challenging pieces of our application is how to handle all of the different types of messaging that needs to take place between users. We need to be able to allow users to communicate regarding the details of an event, and also to send notifications to users about contact requests and event invites. First, we looked at building a solution from scratch because we thought we could just leverage something as simple as WebSockets and maybe a few messaging queues. However, we didn't realize the complexity of the required solution until we began researching it. Eventually, our research led us to what my presentation is about: message-oriented middleware and our selected solution, the Realtime framework. First, I want to give a high-level overview of message-oriented middleware. So, what is message-oriented middleware? Well, it's the software and/or hardware infrastructure that supports message sending and receiving between distributed systems. Some of the common properties seen across many MOM solutions are asynchronous communication, message persistence, and actually there are a few different ways in which MOM solutions handle persistence. Some solutions will store messages indefinitely, while other systems will store the messages until it has confirmed the message has been delivered. And then there's others that will leverage a combination of both strategies. It is this property of message persistence that allow message-oriented middleware solutions to say that they have reliable message delivery. Finally, MOMs have the ability to process messages, and this can include message transformation, filtering, and/or routing. It should be noted that message-oriented middlewares are extremely robust solutions that can provide great value to larger distributed systems. One of the biggest advantages of MOM is that it allows for loose coupling between applications. Two applications that need to communicate no longer have to be tightly coupled due to messaging. Instead, the messaging is encapsulated in the MOM, and a common interface for messaging is provided to all applications leveraging the messaging system. This encapsulation also makes MOM solutions flexible and highly tolerant to modifications made to existing systems. As long as the applications in the message-oriented middleware maintain their defined interfaces, then changes made to either application or messaging system should not affect anything else. Finally, systems that leverage MOM can potentially handle messaging quicker than systems relying on synchronous communication. The main reason for this is that the message-oriented middleware can be architected to parallelize message processing. So one of the main and probably most important concepts of a message-oriented middleware is the concept of channels. Channels are used to transport messages between multiple distributed applications. You'll actually see these implemented in code by using queues. A key feature to note about channels is that they can be concurrently used by multiple applications. There's actually a lot of different ways that you can implement messaging channels, and there's a lot of different patterns, but I'm actually just going to touch on a few of the more common patterns. The first one is the point-to-point. You'll use this when you want to send a message to exactly one recipient. Another pattern is the publish and subscribe, and this is used when you want to broadcast an event once to all interested consumers. And this is actually the pattern we've selected for the Your Tribe application. And finally, there's the data type pattern. Sometimes a system has a lot of different types of messages that it needs to process. In order for the system to properly process a message, it needs to know what type the message is. So separate data channels are actually set up for each type of data. One of the main components that makes up a portion of most message-oriented middleware is the message broker. A message broker is a design abstraction implemented by software that handles message transformation, validation, and routing. It is a part of message-oriented middleware design in addition to the actual physical infrastructure. Currently, there are a lot of existing message broker solutions, which made it really difficult for us to find the right solution for the Your Tribe application. Some of the more common ones I've listed out here. There are Microsoft BizTalk Server, RabbitMQ, WebSphere Message Broker, OpenAMQ, and Realtime Framework. I've actually included Realtime Framework on the list because it's what we chose as our solution, but technically I wouldn't say it's a common solution. However, we decided to use it for our messaging system because it's lightweight compared to most of the other solutions. It works well within our technology stack, and it requires a lot less setup time than some of the other solutions. Now that I've given an overview on message-oriented middleware, I wanted to talk about how the real-time framework fits into our application and to give a high-level overview of how we are using it along with some code snippets. So first, the real-time framework is actually 3 products rolled into one framework. I'll be focusing on the cloud storage offering, which we are leveraging for the Your Tribe application. The real-time cloud storage offering is an API that provides access to a NoSQL database service based on Amazon DynamoDB. It provides real-time notifications to applications subscribed to events for particular tables. So these can be events like putting an item into a database table or updating an item. These notifications then provide a snapshot of the item updates or whatever has been inserted so that no round trips have to be made to the real-time cloud storage to get all of the information to update the application or interface. This allows users to receive data quicker. One of the nice things about real-time cloud storage is that it has numerous SDKs. For the purpose of the Your Tribe application, we'll be using the REST API for our C# API that we're creating, and then also the JavaScript SDK for our PhoneGap application. So here's a high-level example of how we'll be using the real-time framework to allow users to send event invites to other users. The first thing that has to happen is a user creates an event invite with invitees in the mobile client. That gets sent over to the Your Tribe API, which processes the request and then connects to the real-time framework to create a table to store messages for the event, and then it gives the event creator permissions to read and write to that table. Once it's been created, any users who are part of the event can then subscribe to get notifications about the event. So the very first step in setting up the real-time framework is authentication. The authentication for the framework is token-based, and it will be handled by the Your Tribe API and not the client-side mobile application. A user is uniquely identified with the framework by a token which has a role and policy attached to it. Below is an example using curl to show how to use the authenticate method in the real-time framework API. If you look at the code, you can see that we are authenticating a user with a specific token, and then they're actually being assigned the role of subscriber role. So in the authentication example, we had to assign a user a role. The real-time framework allows you to create as many roles as you want. Each role has a policy attached which defines user permissions at 3 levels. The highest level is the database level, which refers to database operations such as creating listing tables. The next is table policies, which is pretty self-explanatory. And then finally, there are item policies, which refer to specific items within specific tables. Below is another example using curl that shows how to call the update role method in the real-time framework API. And this example is actually updating the admin role policy. This policy defines permission for the database and table levels. It allows the admin role at the database level to list all tables, create tables, and describe a table. At the table level, it allows the users to create, read, update, and delete from the table called new table. So now we should be able to authenticate a user with a token, define roles, and attach policies which define our permissions. So now I think we're ready to create a table. So first, it should be noted that for the Your Tribe application, we've actually identified and defined 2 types of tables for messaging. The first is an event table. These tables contain messages pertaining to user-created events, such as an event update notification and invitee chat messages. The second table type is a user notification table. Each user has a table for all messages that pertain to contact requests and event invites. So below I actually have another example using the REST API, and this shows how the Your Tribe API will create a table for a new event using a token that's been authenticated with the admin role attached to it. All you need to do is provide the table name, the definition for the primary and secondary keys, and then if you look at the very end of the request, there's a thing called provision type. Provision type actually defines the table's number of operations per second. And then there's also provision load, which specifies the values for the read and write throughput capacity of the table. So now that we have an event which has been created, and then we've also created the corresponding table in the real-time framework, we need now to send event invitations to any invited users. To do this, your tribe application will put a notification in each invited user's notification table. So below is another REST example, and basically all it does is it places a notification into user 1234's notification table. So it uses the authentication token that has the appropriate role assigned to it with the proper permissions to write to the table called user 1234. So now that the messages are being placed into the messaging tables in the database, the application needs to send these messages to the users in real time if they're online. So when a message is placed in a table, the Realtime framework will send or publish a notification out to all users subscribed to the table update channel. The Your Tribe mobile device client application will be handling subscribing a user to these events using the Realtime framework JavaScript SDK. In the previous examples, I was actually using the REST endpoint because those calls are going to be made in our C# API that we're creating for our application. And unfortunately, there is no SDK for C#, so we're falling back to the REST endpoint. So then for the mobile client, first what we have to do in order to get these events to work is that we need to create a storage reference to the database. And that's where you see the storage reference, and we pass in our application key, and then you actually pass in the authentication token, which is specific for each user. Then next we need to create a table reference. And so in this case for a user, the table reference could be their notification table or any of the tables for events that they happen to be a part of. Finally, then we need to actually apply the listener. And here we're actually applying it on the put event. So when an item is put into, in this case, we have my table. When an item is put into that table called my table, then the user will actually then get pushed out a notification. So then this whole situation will only work if a user is currently online, but we also want our system to be allowed for users that are offline. So in the case of an offline user, when a notification is sent out, they won't miss the notification because it will be persisted in the database. The next time the user is online, the Your Tribe application will query the database based on a timestamp referencing when the user was last online. The application will then update the user's client application with all missed messages. And I guess that's about it. So this was a quick overview of the Realtime framework and message-oriented middleware. Thanks.